All right. Hello, everybody. So we are getting to our final concept for this unit in particular. We're going to jump into covalent compounds. So first of all, covalent compounds are, covalent bonds are bonds that result between non-metallic elements that share electrons. Molecules are when compounds formed when two or more elements are covalently bonded. Bonds can be single, double, or triple. So a single bond has 2 electrons shared. Double bonds have 4 that are electrons that are shared. And triple bonds, that means there are 6 electrons that are shared. So let's dive into each of these bonds individually. So let's go ahead and talk about our single bonds first. So single bonds, again, have 2 electrons that are shared. We'll show these as a dash. And so some examples of this, let's look at hydrogen. So there's H2 here. So there's 1 hydrogen bond. So we're going to kind of go back to our Lewis dot structures, by the way, so you guys can visually see what's going on here. So there's 1 hydrogen element, or one hydrogen element, 2 hydrogen elements. Then they can share. So we circle those because we can share those electrons, So then when we actually write it out like this, that dash right here is what I was talking about up here. So they'll be bonded like that. So another example would be H2O, which is water. So you have oxygen that looks like this. You have hydrogen that looks like this. Hydrogen and oxygen, and another hydrogen, obviously, we can share electrons. So there's our first pair of shared electrons, and this is our second pair. So this is what it'll end up looking like. Now let's jump into double bonds. Double bonds are 4 electrons or 2 pairs that are shared. So here we have O2. So there's 2 oxygens that look like this. Those 2 leftover valence electrons for each of those that are not paired can be paired together, and we can actually show it looking like this when we draw it out with 2 dashes. Another example would be CO2. So there's carbon with its 4 valence electrons, 2 oxygens with its 6 valence electrons. When we go to share these, you can see there's a shared electron, there's a shared pair, another one, and another one. So those are going to be our double bonds. So they're going to look like that. Lastly, we have triple bonds. That's when 6 electrons or 3 pairs are shared. So an example of this would be N2. So there's a nitrogen with its 5 valence electrons. There's another nitrogen with its 5 valence electrons. We can share 6 different electrons or 3 pairs. So 1, 2, 3, and it'll look like this when we write it out. So let's talk about the properties of covalent compounds versus ionic compounds. So covalent compounds are made up of nonmetals that share electrons. These are molecules that can be solid, liquid, or gas, and they have low melting and boiling points, as well as that they cannot conduct electricity when dissolved in water. As far as ionic compounds goes, they're made up of positive metallic ions and negative non-metallic ions after the metal transfers electrons to the nonmetals. And this is what we've been focusing on the last week. This is arranged in regular repeating patterns called crystals. Therefore, ionic compounds tend to be solids. They have high melting and boiling points, and they can conduct electricity when dissolved in water. Perfect example would be NaCl, sodium chloride. Table salt is a solid. When it's dissolved in water, you actually can conduct electricity. So let's talk about about naming these things, as well as coming up with the formulas for these. So in order to determine the name for the covalent compound, we're going to go from the formula to the name first. So first you're going to name the first element with a prefix to indicate how many, and that means like mono, di, tri, and I'll give you a list of those in the next slide. But the only exception is for our first element, you're not going to use mono for 1. If it's there, we just assume it's already got 1, so we just don't add that prefix. To name the second element, we have a prefix to indicate how many, and you add the IDE ending that we've been working with. So some prefixes to know, there's mono, which is 1, di, which is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. These are ones you're definitely going to need to remember. So again, you might want to write these down somewhere. So an example would be to name this compound in particular. So we've got phosphorus and oxygen. And here we've got our subscripts. This will tell us what the prefixes will be. So we're going to have diphosphorus pentoxide, because there's 2 phosphorus and 5 oxygens. Now let's go ahead and have you practice these 5. I'll go ahead and have you pause, work through those, and then we will go from there. So this is carbon dioxide. This is dihydrogen monoxide. This is carbon tetrahydride. This is phosphorus trichloride. So this is an example of where we only have 1 phosphorus. You would not add mono at the beginning. And then number 5, we have tetraphosphorus decaoxide. Now to determine the formula for the covalent compound, going from the name to the formula. So we're going to use those prefixes to determine our subscripts. There are no crisscrossing or simplifying involved in covalent bonds. So that's kind of the one thing to remember when we're doing this. So for example, the formula for dichlorine monoxide. So di means 2, mono means 1. So ClO2. Or Cl2O, my bad, Cl2O. Let's go ahead and practice this. So we've got these 5 here. Go ahead, pause, figure them out, and then I will go through the answers here. So number 1, we have dicarbon tetroxide, C2O4. Hydrogen monosulfide is HS. Pentaphosphorus trinitride is P5N3. Sulfur pentoxide, it looks like this, SO5, and then silicon and tetrafluoride looks like this, Si with F4. Now let's go ahead and practice these ideas tomorrow. If you have any questions, let me know.